Okay, so I'm going to show you how to do some volume scale factors work. Let's just have a quick reminder what we know. We know that if you've got a length scale factor, and let's just make one up for a second, let's pretend it's 10, we should know that the area scale factor for similar shapes will be 10 squared, and the volume scale factor will be 10 cubed. Okay, there's the link between the three scale factors. Obviously it's not always 10, but you know, it's the fact that the area scale factor is the length 1 squared and the volume scale factor is the length 1 cubed. Alright, and I mean, I can kind of show you why this is the case. If we quickly draw a small cube, okay, let's pretend this is a 2 by 2 by 2 cube, and let's increase it by a factor of 10, a length scale factor of 10. This is not drawn to scale, obviously. So 2 times 10 will be 20. All these lengths here will be 20. Now let's have a look at some areas. The area of this front face here is going to be 2 by 2. So this area here is 4 centimeters squared, whatever the unit is 4. And then if we look at this one, 20 times 20, that will be 400. Now look what's happened to that 4 to take it up to 400. It's been multiplied by 100. 100 is 10 squared, okay? Look how the area has gone up. And then if I work out the volumes, the volume of this small cube here is 2 times 2 times 2, so that is 8, and the volume of this big cube here is 20 times 20 times 20. You can use a calculator for this, but that will be 8,000. Let's just show you that on the calculator. There it is, 8,000. See how the volume has changed. To get from there to there, you're times in by 1,000, and 1,000 is the same as 10 cubed. Alright, so I've sort of, well, I haven't proved it's true, but hopefully you're kind of now convinced about this, the link between the scale factors, even if you weren't already. Right, so I'm going to move that off the screen now, and I'm going to show you how to answer a couple of questions so that you can do some of your own from your textbook. So let's start with question 3. Cylinders C and D are similar. The volume of C is 200 centimeters cubed. And you've got the heights of the two cylinders. One is 7 centimeters and the bigger one is 10.5. It wants us to get the volume of the bigger one. Well, I'm going to need a volume scale factor as they're similar shapes. I don't know what that is, but I can work out the length scale factor by dividing that big length of 10.5 by the small length of 7. 10.5 divided by 7 is 1.5. Alright, that's the length scale factor. So the volume scale factor will be 1.5 cubed. Okay, you should always be writing this stuff down when you answer questions. Alright, some of you are still submitting work to me where it's just the answer, you know, which you may have got from the back of the book, of course. You need to be showing your working. So there is the volume scale factor there. So if I want the volume of D, the bigger cylinder, I will take the volume of the smaller cylinder, which is 200, and times it by this volume scale factor. So 200 times by 3.375 gives me 675 centimeters cubed. So that is question 3. That's your sort of basic volume scale factor question. Alright, question 4, let's just scroll this down and have a look at it. Question 4 is basically the same question, but this time you're being told the bigger volume. Alright, I will quickly go over this, but I think this one, and I'll do it here, look, just to save a bit of space. Yeah, it's just a very similar question. We're just going to divide at the end to get the smaller volume. So, I'm going to get the length scale factor by dividing 12 by 8. Alright, so I think that's 1.5, but let's just check. Yes, it is. So the length scale factor is 1.5. In fact, it's the same scale factor, sadly, as before, which means the volume scale factor is the same as before, 1.5 cubed. Alright, so to get the volume of F, the smaller one, vol F is going to be 648 divided by 3.375. Alright, because it's the smaller volume. If you think about what you're doing, you'll always know whether you should divide or multiply. Alright, because if I multiplied, I'd get a bigger volume, and that just wouldn't make any sense. There's the answer. Right, there's another type of question that I want to see if I can find. Yeah, here we go. Question 6. Okay, just move this up a little bit. Question 6. Prisms L and M are similar. The volume of M is 512 times the volume of L. Now that's a funny way of telling you the volume scale factor. Okay, if the one volume is 512 times the other one, then that's the volume scale factor. Hopefully this is a cube number. I have a funny feeling it is a cube number, because the length scale factor is the cube root of that. Okay, think about the opposite of cubing something. To go from here to here, you cube the number. So to go from here to here, you'll have to do the opposite, which is cube root. Let's see whether that is then a nice answer. Yes, it was 8 cubed. Look, there it is, 8. So the length scale factor is 8. Okay, so now if you look at those diagrams, that X there is equivalent to the 2 centimeters in the smaller shape. So it's 2 centimeters multiplied by the length scale factor of 8, 16 centimeters. And the Y is equivalent to the 56, so 56 centimeters. But I won't be timesing it by 8 because that'll give me a bigger answer. You're getting bored of me saying this. We want a smaller answer, so we're going to divide it by 8. Alright, and that will be 7 centimeters. So that will be the answer to that. Lovely.